Hello everybody. In this video session I am going to talk about TM1637 IC. As you can see, this is a integrated circuit. It's about 20 pins are there, and which has a VCC and ground, and also it has a 2 pins which is nothing but clock and digital data, and these pins are used to connect to the 7-segment display. These 2 pins basically is going to communicate with the external microcontroller. This IC is capable of connecting 8 7-segment display, and also it is also used for keyboard scanning, but in this session I am not going to discuss about that. We can also adjust the brightness of the 7-segment display, and it's going to connect to the 2-wire interface.
Before we get into the more details about the IC, let me introduce about the display. We have 2 types of 7-segment display, which is called as a common anode and common cathode. This is a 7-segment display. In this demo there is no decimal point included. For example, you want to display the value, let us say like a 0, using common anode display. This is hexadecimal digit. We assume that segment A is connected to the bit 0, segment B is connected to bit 1, and so on. In case if you use common cathode, obviously it's going to inverse. That means cathodes are connected common. If you provide 1, that means the segment is on. So if you want to display 0, so we should have the data like 3F. Like this we can code mostly all numerals, and also we can code few alphabets also. For example, like A, you can code this is the value for A, or you want to code for H, this is the value for H. So we can code the possible values of alphabet as well as numerals by using 7-segment display. Whatever data you code or whatever data you get, for example, you want to display H in all 4 7-segment display of this kit, just you have to fill 0x76 in these memory locations. Okay, there are 6 memory locations. As I told, this IC is capable of connecting to 6 display, whereas in this board we have only 4 displays. Okay, so if you fill in this 4 display as a 76 76 76 76, you will get a letter H H H in all 4 display. Whereas if you want to show like 0, you have to fill 3F in all the memory locations. Okay, this is how it works out. Whereas it's not that easy to fill the value directly into the memory location. As I discussed earlier, this IC uses only 2 pins, which is nothing but clock as well as data. Through these 2 pins we have to communicate this information to the IC, and we know very well these hardwares are generally meant for slow responding. We are not going to work with the very high speed. So based on this clock and the data, we are going to transfer the information from the microcontroller to the display IC. Whereas there is a standard which is available on this particular topic, which is called as a I2C bus specification. This IC follows the same specification, whereas we are not using built-in I2C hardware which is in our MSP430. We use simple digital IO lines, whereas we program this protocol in terms of simple set and reset, and we get the work done. Whereas it is also possible to use built-in I2C hardware subsystem, but which we are not used in this example. You may need to read this document for any kind of documentation or to understand what is I2C and who has developed the standard, and why it has become popular. There are so many information is there which you need to spend. But I can tell you in a simplest way, it's basically meant to communicate using only 2 wires, as simple as 2 wires. And you can see here, if you can have a microcontroller, and also you can have a group of microcontrollers, and you can also have a bus controller which can communicate to various IO devices through only 2 wires. So why not? You will find this as a good feature, because the number of IO devices, as you can see, we have n number of IO devices, but all of them are interconnected using only 2 wires. Now, how the system will communicate, or I mean to say how the microcontroller will communicate to the external devices, there is some specification on that, or there is a protocol on that. And you can see here we are using only serial data and serial clock, the 2 wires. And this is the first condition. You can see here the 2 lines are initially held as high. The data line will have a transition from high to low. This is called as a start condition. Same way, you can see the clock is in low and also the data is low. Then the clock comes high. That means we are keeping the clock as a high, and we are having a transition of the data line from 0 to 1. This condition is called as a stop condition. So very basic step is a start and stop. Once you have a start and stop, in between you should have some address. That means, as I shown, the n number of devices are there. You should be able to send the device address. So once you send the device address, then we should be able to send the particular memory location address or the IO devices address, and then the data which you want to transfer. But this all of them has to be done through the serial communication, that means bit by bit. And as you can see here, first we have to initiate the start condition, then we have to send the data or address, and also the IC will respond with the acknowledgement. We have to receive the acknowledgement also, and we have to communicate the data. You may need to read this document for more information about I2C protocol. Now we'll just go back to the IC data sheet. As you can see here, we have to give a start condition and the command, and we have to get acknowledgement, and as well as we have to give data. There are 2 types in which you can write the data to this IC. One, by incrementing the address and automatically. That means there are, let us assume 4 displays there. The address of first display is 0. You will put this address only one time to the IC. Once you write the data to this particular memory location, automatically the memory will increment to the next location. That means you have to simply send the data to the next location. If you do such things, that is called as an automatic incrementing. In case you want to send the address of each digit and then the data, then you have to go for a fixed address mode. Okay, so there are 2 modes in which you can operate this particular IC. And you may also see here the various commands which is available. These 2 bits are don't care state, and when we have here 0 1, can be anything, and last 2 digit 0 0, that means you are trying to write the data to display register, and automatic address incrementing and fixed address. So as I told, we are going to use the fixed address, that means 0 1. So let me consider this as a 0 0, that means 4, and again this 0 1 0 0, that means 4 4. So we will have a fixed address in our program as a 4 4. and this is to set the address for the command. And you can see here we start with 1 1. Again I assume this as a 0 0, that means it is C, and this comes as a 0. So it gives us actually C0. To set the address, we should make the first 2 bits as a 1, that means C, and this is your address locations like 0 1 2 3 4 5 like that. Okay, so again this we will be using it in our program. And display control, we can adjust the brightness, and you can see from minimum to maximum. That means first bit is 1. Again assume this as a 0, that means 1 0 0 0, and again it starts from 0, that means 80 to 8F. You will see the brightness from minimum to maximum. And this is a flow chart how you can implement. So we have to initialize and write the command or the memory address which you have to send, and transfer the 1 byte of data which you want to display, and you have to repeat this task. Okay, and we are not going to use the key press. There is a sample program is given here, but it is for the different microcontroller. I have modified to our MSP430, and as you can see here, this is our main program is starting point, and I say initialize. This is a routine, and we make port 4 bit 1 and 2 as a output. As I told you, these 2 pins are used for SCL and SDA. And then we have a function called display, where we have the value here 0 and 5. Like I want to display 5 4 3 2 in the display. And what is the location of the first digit is 0 segment, and 1 and 2 and 3. So when you run the program, you will see 5 4 3 2 on the 7 segment display. But how it happens? From this point, the system goes to the display routine with the value here 0 and with the value here 5. And we have here start, as I told, the start condition, and writing a byte as a fixed address. And you may see the program here. What is the meaning of fixed address? Fixed address means 44, which I explained you earlier. And again starting address is C0, again which I explained you earlier. And these are all the data. That means this is 0 1 2 3 are stored in a order here. And the system, what it does, it comes to this location, it gives a start condition, and you can see here the protocol standard like start condition. We are keeping both the bits initially high, and we are changing the data bit. This is start condition. So we give a start condition, then we write a address, and we give a stop condition, and again we give a start condition and write the bit address. So what is the bit address here? Whatever value you pass, 0 or with starting address is C0. Okay, so this is C0. So these value will be sent to the IC, and then we send next the data which you have to display. As you can see, if I display as a 0, so from the array we are selecting the value for 0 and we are writing, and then stop, and again we are setting the brightness. It's not necessary you have to do this one every time, but it's better to make sure that you are giving it maximum brightness. And if you look at the right byte, again it's a function which is written here. In every byte we have 8 bits. We are sending the data serially based on the bit value. If it is 0, we send out a 0 in a particular pin. That means in a bit 1 is a data line. Okay, if it is if it is 1, we are sending 1. If it is 0, we are sending a 0, and we keep shifting the data every byte, every bit, and then we go on into the looping up to 8 times. That means you are transferring all 8 bits. This is the job of this write byte function. And we are trying to take acknowledgement. Acknowledgement is nothing but we are trying to check this particular status happened in our system. It's nothing but in our display card. And the program as such, if you run, that means you will see the number 5 4 3 2 on the 7 second.